How can you apply formulas to find the area of composite figures? Think about this question during the lesson. Delia drew this figure. How can you apply formulas to find its area? You can decompose a composite figure into smaller polygons. The sum of the areas of the smaller polygons is equal to the area of the original figure. Step 1. Decompose the figure into shapes whose area formulas you know. You can decompose this figure into a trapezoid, a parallelogram, and a triangle. Step 2. Apply the formulas for the areas of a trapezoid, a parallelogram, and a triangle. What is the total area of the figure?
Select your answer.
The total area is equal to the area of the trapezoid plus the area of the parallelogram plus the area of the triangle. The area of the trapezoid is 63 square centimeters. The area of the parallelogram is 28 square centimeters. The area of the triangle is 21 square centimeters. The area of the figure is 112 square centimeters.
Johnson decomposed the same figure in a different way. Show that he will find the same area that Delia did.
Total area is equal to the area of parallelogram plus 4 times the area of a triangle. So this time, Delia took the parallelogram, the blue portion, and then she added that with triangles. So she made the trapezoid into 3 equal triangles. So now there's 4 triangles. So I wanted you to understand where that came from. So now we have 7 times 1/2 plus, I'm sorry, not 1/2. My apologies. 7 times 6, I'm sorry, 4. Looking at the wrong numbers. 7 times 4. And then we have 4 here because there's 4 triangles. And the formula for a triangle is 1/2 times base times height. So the base of the triangle is 7, the height is 6. So now 7 times 4 is 28, which they have here. And then 4 times 1/2 times 7 times 6. So first we need to do 7 times 6, which is 42. And then 1/2 times 42 is the same as saying 42 divided by 2. And that equals 21. So that'll be 21 times 4. And then 4 times 21 is equal to 84. So in here is 84. And then you add those together and you get 112 centimeters squared. So we have the same area, 112 centimeters squared.
Josie has set aside some space in her bedroom to use for exercise. Find the area of her exercise space.
One way is to decompose that figure, and decompose means to break apart. So we're going to decompose that figure into a trapezoid and a rhombus. So they've taken dotted line to use to separate. So we have our trapezoid here, our rhombus here. And then they found the area of both parts and then added them together. Another way is to take the same shape, and now we're going to break it up into trapezoid, two trapezoids, and a triangle. And then you find the area of the two trapezoids and the triangle, and then you add them together, and that gives you the square feet or area as well. And as you can see, both are the same answer, just two different ways to get to the same answer.
Show that the composite figure and the trapezoid have the same area. Then find the area.
So I'm going to drag the familiar shapes onto the composite figure. So I'm going to take this, put it here. That's a triangle. Then we could put a rectangle here. And this little triangle. Oh, no, don't turn it. No, don't turn. I'll turn it once it gets over here. Uh-oh. Uh-oh. There we go. Almost. There we go. Good enough. So the point is to see that the various shapes make up the one big shape. You could do the same with this one. If I put this rectangle here, then we put this one here, and the blue can go here, but I gotta, hopefully it turns around the right way for me. Oh, almost got it perfect. You get the idea. Alright, so again, little shapes making up one big shape. Now we're going to look at the different shapes, and we found the area of both, or they found the area of both, and they both are equal to 132 and 5/10 meters squared. Even though it's two seemingly different shapes, they're made up of the same size shapes, and so that's why the area is the same. Now we're going to find the area of this composite figure. So let's break apart, or decompose is the word we need to use. We're going to decompose the shape. So let's see here. So I have decomposed the figure, and if you were to do this, you may have decomposed it a different way. But I chose to make one rectangle, two triangles. So now the triangles first. We have area is equal to 1/2 times base times height. So, excuse me, I need to find the base of my triangle. I do know that from here to here is the 25 inches, but I only need this space. But I know from here to here is 15. So that means that I can take the 25 and subtract it from 15, and that will give me the 10 inches just for here to here. So now in my formula, my base is 10, and now I need my height. So here it shows me that it's 4 inches and 4 inches. 4 plus 4 is 8. So my height will be 8 inches, because that same height will translate there. So we have 1/2 times 10 times 8. I'm going to do 1/2 times 10 first, which is taking 10 and dividing it by 2. So that's going to give me 5. So now I have 5 times 8. That gives me 40. So my area of the first triangle is 40. Now I need to find the area of the second triangle. So again, 1/2 times base times height. And so we have 1/2. My base will be the line drawn here, which I found for the other triangle was 8. So my base will be 8. And then my height of that triangle would be if we look here from here to here, it tells us that that's 4 inches, right? So if I found the height of this triangle, I can extend it out this way, and that'll still give me the same 4 inches as the height. So I'm going to multiply that by 4 as my height. And so I have 1/2 times 8 times 4. So now 8 times half is 8 divided by 2, which is 4. And then 4 times 4 is 16. So area of that second triangle is 16. Now we have the area of the rectangle, which is base times height. The base is 15. My height is 8 inches. And then we have 15 times 8 is 120. Now we add up all of the areas of each of the shapes. So we have 16 plus 120 plus 40 is equal to 176 inches squared as the total area of that shape.